Hello. Oh, you.
Is
Sorry
that
about
better?
that. Yes.
All right.
We now have our presentation from Dyemansion from Michael Shorr, Head of Application Consulting, of creating the new standard for high-value end-use parts. Michael Shorr has 7 years experience in the world of additive manufacturing with a focus on hybrid tooling, design for manufacturing, materials, prototyping, and scaled production. He possesses a strong skill set geared toward end-use products and application-specific goals. Thank you, Michael, for joining. And if you don't mind sharing your screen as well, that would be great.
Of course. All right.
Perfect.
All right. Hello, everyone, and thank you for joining us tonight. And a special thank you for Link 3D, of course, for hosting all these events. It's a really great opportunity for all of us to connect digitally still and not miss on an opportunity. So today we want to talk a little bit about how we want to create the new standard for high-value end-use parts. And again, my name is Michael Shorr, and I'm the head of application consulting for Dyemansion. A little bit about myself. As I mentioned, on the application side for Dyemansion, based out of Baltimore, Maryland in the US. If you're looking at these numbers here, they do seem like a little bit, but I started at a pretty young age, actually growing up in my father's automotive shop. I was working on vehicles, repairing engines, transmissions, and full customization and builds. Learned quickly the need for advanced manufacturing. From there, I moved into the aerospace and defense industry, where I focused heavily in subtractive manufacturing with the help of additive for prototyping and implementation of housings onto different applications. After that, I moved into the consumer goods section, working with Under Armour for a few years, helping lead the team for advanced manufacturing additives specifically for consumer goods, focusing really deep into post-processing strategies and volume consistency, especially when you're talking a few thousand parts and each one has to match footwear, whether left and right. Each component always has to be identical. So all in all, I do have a little over 7 years of additive experience that focuses, as we just mentioned, in design for manufacturing, hybrid tooling, and end-use products. And a little bit about what we're actually talking in today. So we're going to go through what the status quo is, so what exists currently in the market, and some of the challenges that we see with that. After that, we're going to go into what we provide as an opportunity from Dyemansion, our print-to-product workflow. And then we'll dive deep into the tests and results from how we actually compare these two different technologies. So to start us off, let's talk about how AM is going to change our world. Many of you already know this as we're already diving into this industry. But when we think about additive manufacturing, we think about immediately how do we reimagine products and how do we rethink business and reinvent what exists in current manufacturing. So when it talks about products, a lot of the conversations that are happening this week are always about full customization. The opportunity to change each individual product as you're creating that build. It's a huge advantage in AM. When we're talking about reinventing manufacturing, this is actually an amazing time to see this in action because we have the huge opportunity to reduce the production of CO2. We see that currently with heat map images of the world based on the production levels that are changing with the world crisis that's happening right now. Another big advantage to AM is actually on-demand manufacturing, which reduces your inventory because you go from hard part inventories to digital inventories. The last thing is actually faster innovation cycle. So with traditional tooling, with traditional manufacturing, we could take up to 30 days with a huge lead time and long cost that's associated with that. With AM, we could actually be printing different molds or different tools every single day, let alone a few in each build. So what do we actually need to have happen and change this industry? We need to be able to push this into high value and end use parts, and we need to do that at scale. And this scale is in different sectors. So we see that in consumer goods through footwear and eyewear. We see in auto bottom left there, you see an actual part there from our Daimler buses. And we move it into the medical sector as well. And each of these parts are high value and they can be done at high scale. So what do we do at Dyemansion? We turn 3D printed parts into things like high value eyewear. We can turn all these parts into opportunities like this automotive part, which is actually a rest inside the automobile. Or we could even turn some of these parts into high fashion jewelry. And lastly, one of the big opportunities here now is in the medical space. So what's currently available in the market, and why does it not meet what the industry needs? The big reason here is because it's a manual approach. What exists right now is your manual sandblasters, where you have a couple different technicians who might be operating them on different days, and we see opportunities for damaged parts, and that could just be as simple as technician 1 does it a little bit different than technician 2. Their distance from part to nozzle might be a little bit different. Their blasting strategies, or even just the duration in that chamber, might be different, and you're going to have inconsistent results every time. When we talk about dyeing parts, there are a couple options out there that are very easy to start with. The image that's on the bottom there is actually a pot dye sample. It's what's very common in the industry right now. But again, that's a very non-reproducible approach. As you can see, it's a hands-on approach. So if you have different technicians doing it, you might have different chemistries or mixtures each time. And again, if you have a very specific application, it's nearly impossible to find any kind of ISO certifications around that. So where do we see this as an opportunity for us? We need to produce a manufacturing-ready post-process solution that meets these standards to create these high-value end-use parts. And this is where Dyemansion built this entire workflow. So we start off with the basis of cleaning. As we showed in the last couple images there, where it's a user-controlled process, we have a lot of issues and opportunity for failure. With an automated approach, you eliminate all those issues. Not only that, but that technician could then be doing something else during the cycle time. Moving into the surfacing opportunities, this is where you really create a good appearance for the part and a good basis to your next steps of post-process. So you have two pathways here: mechanical process through our PowerShot S, or a chemical process through the PowerFuse S. Lastly, you go to the aesthetics, and that's where the deep dye color machine comes into play through our DM60, and that's what we're going to dive a little bit more into now. So where do we focus all of our efforts? We started mostly in the powder bed technologies through your SLS and MJF, with all the most commonly used materials that exist in the market, your PA12s, your PA11s, and your TPUs. And lately, we've actually moved that into some other technologies through SLA and CLIP, through the EPUs that exist through those technologies. And a big one here is actually ULTEM through FDM. Now, ULTEM is one of the highest volume parts in aerospace industries. It's a very difficult part to push to the next step of raw part to a finished product that's in the plane. There's a lot of extra processes that go before it's a painted part that goes into it. And that's where we can come into play, because we can actually eliminate all those manual processes prior to paint. So a little bit about Dyemansion themselves. So we were founded back in 2015. We're located originally just outside of Munich, and now we have a facility in Austin, Texas as well, with a team of well over 60 people now. So we actually our founders did start the company way back in 2013 with the idea of 3D printed smartphone cases. And it didn't take them very long to realize that wasn't a successful approach. And that's when they moved into the home of coloring. So in 2015, as you can see, it was a pretty eventful year. Initially created the birth of Dyemansion, moved into an initial seed investing round. And from there, we launched our first product, which is our DM60. The DM60 was in the market for quite a while, and it was an amazing opportunity for customers to create new end-use parts. But the bad side was we had no controllability of what happened from print into our color machines, what those couple processes were, from depowdering, surface finishing, and whatever it might be. And then we saw challenges with deviations in part quality at the end. So that's when in 2017, we really backtracked quite a bit and decided we need to standardize this process and create a controlled approach prior to color. So Dyemansion released our full workflow, which is a PowerShot C, the PowerShot S, and then the DM60. As I mentioned in the previous slide, as you saw the full workflow, what this did is it actually controlled all those user processes, so we can guarantee a reproducible finish afterwards. So in 2018, we realized that we really wanted to push even further in R&D and development and continue our expansion. So we had our first Series A funding round of a little over 5 million euros. And that's when we expanded into the US. We grew our North American team, serving all of the Americas. And we also launched a couple of new color lines, very specific applications here. So we have the automotive line. So it's one of our X lines, which actually meets all the UV standards for automotive interiors. And then we also released a full line of neon colors. At the end of the year, if anyone was available to attend Form Next, we actually unveiled our PowerFuse S, which is our brand new clean vapor technology. This is a vapor process to chemically smooth parts. Some of the industries that we serve currently, so we do focus on consumer goods, medical, industrial, automotive, and contract manufacturers. These are just a few of the names that we have full equipment sectors in. So we have well over 600 customers worldwide and more than 300 globally installed systems. So now into the nitty-gritty of what we're actually getting into here. So the manual process first, all this industrial equipment, and then we get into some of the vapor fuse surfacing versus the polish out surfacing. So into the pot dyeing system, we'll start with how it's all beginning and what the commonly used system is now. This is a manual process. It uses cooking pots and conventional textile dyes, which can be very useful for the average beginner or even small bureau that exists out there. It's an extremely low cost of investment. You can even get some of these things off the shelf in your local stores. And with today's day and age, you'll likely find a quick YouTube tutorial on how to do it too if you've never seen it before. With this, there's quite a bit of unfortunate advantage or disadvantages to this process. It is very labor intensive, so you're always going to need a technician there on site to be flipping parts, turning parts, stirring them, or holding them underwater. And it's also not a clean solution whatsoever. If anyone's ever seen a service bureau or a production facility or even a prototyping facility with one of these setups, chances are it's put off into the side or the corner, and it's a pretty messy corner as it is, let alone the storage situation that they might be handling their dyes in. Because it is a labor intensive approach, it's also very inconsistent. And it's going to be very highly dependent on the shelf life of your mixes too. So it's going to be dependent on who the technician is mixing some of these new chemicals. You're not always going to get the same exact results unless you have very precise equipment to measure them all out. And then you also have to worry about how long is it going to last on the shelf if you don't finish off that dye the first day. Unfortunately, because of this approach of a low cost investment with simple pot cooking apparatuses, it's also geared towards small volumes and small parts. The last two things are very important if you're looking at high value. So with these dyes and the setups that there are, they're not really set up to penetrate the part deeply with the pigment. So the parts fade quickly under weathering conditions. And again, there's almost no ISO certifications that you can find for any of these dyes that exist on the market that are off the shelf. So how does that compare to Dyemansion's equipment? So the deep dye coloring machine from Dyemansion is actually a full industrial setup, complete traceability, and it actually uses cartridges to help push this a little bit further. It's an automated process, so the technician actually has zero interaction with the part once it's in the machine. All they're doing is scanning the cartridge, which tells the machine what it needs to be doing for what material and how it's running. Then they actually can walk away. Because it is using a cartridge-based system, it has that traceability, so we can actually go all the way back to the recipe. If there ever was an issue, we can understand what batch that recipe came from, and if there was a problem in the pigment itself, or if it was all traced down into the machine. We can track the heat values in the machine and how the machine was actually working. With this, we offer almost a near unlimited color option and also the ability for color matching. So if corporate colors are key, or even matching skin tones on some of the medical devices, that's fully capable. The big benefit here is also we can meet all of your ISO certifications that exist on the market. And we'll get into that a little bit more later. And as I mentioned, with the seamless integration, it allows for reproducible results. And if we want to dive into a little bit further, when you're looking at your ROIs, we do offer a reverse osmosis system for guaranteed water results coming into the machine, and also an add-on reservoir for customers who are running black cartridges on multiple uses for a single cartridge. Now, with any piece of equipment that exists in the market, there are some downsides. So it is a little bit longer process time. We're looking at around a 2.5 hour process time. And because it is a complete closed system, you are limited in that batch because we do have to worry about water displacement too when you're putting parts in there. Into that DM60 a little bit more, as I mentioned, almost a complete limitless color options and standardized database for your tailor-made recipes. It is based off an RFID chip, so it has that reproducible and traceable results no matter what. And of course, we have ISO certifications. And for the standard process for your SLS parts, your MJF parts, or even some of the EPUs, we're running around a 2.5 hour process from a raw part to a finished color part at the end. This is just a short snippet to show you what's happening there. And I do hope this is working for everyone trying to stream this. But what you can see is actually the dye going in, it's a water bath. And what's happening is within this process, it's using a combination of heat and pressure to actually separate some of the molecular levels of the chemistries of the polymer, allowing that pigment to get in there. And then it seals it back up. So we can go from your SLS parts to a dyed finished part. And even your MJF parts are capable of running through this machine as well. So how is this completely controlled and reproducible? It's all based, as I mentioned, off that cartridge. That cartridge has an RFID chip, but it's based off of parameters. Just like if you're running your printers and you have different materials in there, you're not going to run the same strategies or parameter settings for a PA12 versus a P11 or even a TPU. So all those things really play a factor into coloring as well. So within that RFID chip, it does have a tag on the back that understands what your layer thicknesses might be if you're running 120 microns or 80 microns or whatever that it is in your process, what your powder refresh rate might be, orientation within your build, and it's also based on what material you're running, and then the finish that happened before that. So if it had a tumbling finish or a power shot finish, or even if it was just your own process, all of that needs to be put into those. Now that cartridge is then scanned, tells the machine what needs to happen and how it needs to happen, and it guarantees that perfect reproducible result no matter what, even if technician 1 is doing it or 2 years from now a new employee is doing that same process. So we do offer the largest color variety available on the market today. We have 17 core colors in Dyemansion and well over 170 raw Pantones. As I mentioned with our special color line, we have 4 neon colors, and we do have a UV stability within our black. And the reason we only have one at the moment is because automotive companies at this time are very specific on their interiors. So black is kind of the common ground. So we started with that as a baseline. And as I mentioned with the corporate colors or even skin tones matching your medical devices, that's a near unlimited opportunity of colors. So into the actual test that we did here. So we ran it off of base materials. So your 2 highly common materials used in the market now. So EOS is PA2200 and HP standard PA12. We ran it in 2 different processes. So our standard DM black cartridge, and then against the most commonly used textile dye that exists in the market. And we had 2 different finishes for this test setup. We had a raw finish, and then we actually did it through our PowerShot S finish. The test itself, so we ran the light and heat resistant test, which is actually the automotive standard for interiors. We ran a scratch resistant test and then a color fastness test, which included washing, bleaching, and then perspiration. Starting with the first one, so this UV light exposure is at 135 hours, which is that ISO standard for automotive interiors, as I mentioned. It's really important to understand here the visuals. So the top row is actually your DM60 approach, the DM black. On the left side is your PA2200, and the right side is your HP PA12. As you can see, there's not a lot of big change there. But on the bottom two, it's a huge visible change. And that's actually what the standard conventional textile dyes. The biggest thing to understand is that in this industry as a whole, the average delta E values that you want to see change usually want to sit below a change around 5. With the pot dyeing systems, we're seeing values well into the double digits. But with the deep dye coloring system, we're seeing values below 5. And that's just with the standard DM black. When we move into the UV standard range of the automotive line, we see much better results as even further. From the scratch resistance, we actually didn't see a huge difference on pot dye versus the DM60 dye. And that's mostly because that has to do more with the surface quality than it is the color itself. Into the color fastness, so we're going to focus in washing. If you want to read further into bleaching and perspiration, we can hand off a white paper to you all later. But into washing, you can see on the left-hand side, those are your textile swatches. So essentially what happens in this test here is you have your printed part that is then dyed through either process, and then it is rubbed against these different textiles and composites on a certain number of times based on the standard. And what we're looking for is a transition of dye onto that textile. So we can see that with the DM black on the bottom of each of these 2 rows, had a much better result. And visually, you can see that pretty clearly. What we're looking at and comparing it to is actually a grayscale value of a 1 through 5. 1 being the most change possible and 5 being the least change. So with the DM60 results, we did see values around 4 to 5s. And actually the textiles, it wasn't terrible, but we did see a much lower 4 value on those. And as I mentioned, if you do want to look further, especially into the perspiration, if you have eyewear applications or things like that, please do talk to me afterwards and we can dive deeper into what those results look like. Again, as I mentioned, these are all listed in the white papers. So the white paper we're releasing is actually going to be released early next week, an exclusive. So that's going to be really deep into the manual pot dyeing versus the industrial deep dye coloring system. And you'll see there all of the actual test setups, the results, and even industry applications that you can see applicable to that. Now, if you want to read more about different applications, you can look into the automotive line color white paper, which goes really deep into automotive applications and what those UV standards mean and what they are, and what the results compared to from our standards. We also show off our RAL colors through SLS, and then we also have color options for MJF. Now, when we look at surface quality and a good high value part, it really needs to have a great surface finish to meet your application or standard needs. So you have a couple options, of course. You can have your raw part, which is probably most useful in your non-visible applications or your base customer approaches or even some of your prototypes. And then we get into the next two levels of better quality. So you got to your PolyShot S, which is our power shot system, which gives a really great haptic feel. Or if you need a completely sealed and smooth surface, we go to our vapor fuse system. And that vapor allows that part to actually completely seal the surface. Deeper into the PowerShot S, so it's a mechanical process, as I mentioned. It does achieve a semi-gloss finish. At the moment, it is the most effective solution on the market. It does improve your scratch resistance. And of course, it is a very short cycle time. Now, if we're comparing that directly to the vapor fuse system, it's a very different setup here because the vapor fuse is a much more high standard approach. It does create a completely sealed and washable surface. So it allows that ability to get into the medical field and even right into the operating room for a washable surface. The vapor fuse system is a true closed loop system, which means there's no extra equipment needed to run the system. There's no consumables needed. There's no external components whatsoever. And it is fully ready for automation and Industry 4.0. And to dive deeper into the PowerShot S, so again, as I mentioned, it is currently the most effective technology to get to that end-use finish part because it is only a cycle time of 5 to 15 minutes for your standard mid-size printer. Full batch can be run in there at one time. It does increase your ability to get maximum color results because you are creating a more standardized approach to that finish. And this is just a really quick snippet to show you what's happening in that machine. So as I mentioned before, because this is a mechanical process, those are the blasting media that's actually impacting on the part. And what we're seeing happen here is it's actually impacting and knocking down some of your peaks and valleys. So it's reducing that roughness that you feel, allowing a much more haptic feel and a better finish. So when that color is then applied to it, it's a more even approach. And this can be done through SLS and even your MJF processes. And the last image there shows after a color as well. Deeper into the power fuse system. So this is a clean technology, fulfilling all of your industrial health and safety standards with no waste whatsoever, as I mentioned. So there's no consumable that you're interchanging. And the solvent that we're actually using is completely approved for food contact. And you are creating a completely sealed injection molded-like surface. And when I say sealed, it is washable as well. The cycle time is dependent on your density of materials and the softness of it. So it could be anything from your 40 minutes all the way up to 80 minutes as needed. And this is what's happening actually in that machine there. So again, this is a vapor technology. So that vapor is introduced into the chamber, onto the part. And when it reaches the right temperature, the vapor actually condenses on the part. And what it's doing, it's reacting with the molecular level of the molecules. It's actually causing them to agitate and shift a little bit and realign, creating that sealed, perfect finish. Now, what's important to see here is that this process can actually be done on all of your materials that you want to throw in that machine. So all of your standard polyamides and even to your elastomerics. So what did we test here? So we tested again the standard materials that we see as the highest volume in the market right now. Your EOS PA2200 again, your HP PA12s, and we even threw in the Lehman and Voss TPU. We converted in 3 different surface treatments, so no treatment at all, the PolyShot finish, and then a vapor fuse finish. And we tested against roughness, gloss, and water repellency. And what we can see here is a visual, very clear imaging to understand your peaks and valleys. That raw part's all the way on your left-hand side there of your top two are your PAs, and the bottom one is your TPU. And what's really important to see here is that with the power shot system, we do see a great reduction in surface roughness in the mid 40 percentile range. But what you can see right away is that because it's a mechanical process, it doesn't really do a whole lot to your softer elastomeric materials. And that's where the vapor fuse system comes into play the biggest. So with that, you can see right away that percentage is 98%. It's an incredible decrease in surface roughness. And even with your other polymers, we do have an incredible reduction in surface roughness. Now you can read much more about this particular process and the testing that we did in our white paper. We have all the tests and the results. And again, as I mentioned, your further fields of application that you might find this useful for. So how do we actually get this running? How do we move this into your production line and give you the opportunity for high value parts? So what we can do is what our workflow covers, all the industrial needs, delivering your high quality parts, reproducibility. It's completely geometry independent because as I mentioned, it's the different processes. It doesn't really matter what you put in there. It does have the ability to reduce costs, both in labor and time. And we do have certifications around it with all full Industry 4.0 ready on all machines. Again, this is just an understanding of what that workflow looks like. So we can start off with the Power Shot C's, your basic cleaning opportunities, push that into the better surface finishing through either mechanical method or chemical method, and then finishing with the coloring setups. And how do we get started even more so? You can try it through the free benchmarking or even on-demand finishing, or you can even go in with your parts, live benchmarks through our Munich location, and coming soon in the early summer, our Austin, Texas location. And please do stay in touch. I know this is a digital conference, so it's kind of hard to meet afterwards. I will stick around for a little bit. But again, I want to thank you all so much for joining me and being part of this. And you can find my contact information here. And I guess now we have a couple minutes left for any potential questions.
Hi, Michael. Thank you. Just quickly, since we are running a little bit over on time, we do have two questions, though. One from Brad. Does this system work with PolyJet or FDM systems?
Yes, it does. So it depends on what systems we're talking about. With the PolyShot systems, not as applicable there, but we're talking about the vapor fuse system, yes, because it is a chemical process. FDM is a big market for that one right now, especially. With the PolyJet systems, not as much there just because of the base of the material.
Awesome, thank you. Final question. Are you able to use organic or natural dyes? Are you able to create color patterns like a wood look or a marble?
So because this is a bath cartridge system, we are achieving a single color at a time. So if we're looking for a mixture of colors or like a pattern look, that's not necessarily achievable yet in this system, but we are very much aware of what the market needs are shifting towards.
Awesome. Well, thank you so much, Michael, for joining us today. And I believe we are having another networking session in 30 minutes.